few of like it's...
Okay, and now recording is started.
It just needs webcam, so...
Yeah. And I'll make the webcam take the entire screen.
Yeah, cool.
Why have you disappeared? Stop doing this.
Do you want us to just get you a pretty face, or do you want me to get the demo?
I'm easy. I'll just quickly show some examples. Yeah.
OBS has decided that it does not want to show the camera, but now it does.
What camera is this? This is my machine. Yeah. Yeah. Yeah, of course.
It's just, I have just one friend, right, who, like, the nub on their ThinkPad is, like, really soft.
Okay.
There are 3 types you can get.
Yeah, but oh no, they're...
Okay, now we have
it's a
full
Windows
screen
XP thing.
thing.
Right, yeah.
Yeah, and then you can just retime that later.
Okay, like that.
The ThinkPad nipple.
Yeah. I've just been comparing them because there's just one really soft one. And like
now recording. Oh, yeah. So when you record on that, it doesn't record on here.
Oh, sorry, I'm an idiot.
That's fine. Yeah, if you just point it in that direction, the video and the audio will be recorded on the OBS recording.
What about this though? Isn't this the fun? It's not me. Oh, we want to look at this, right?
Oh, yep. I got you. Oh,
All right. Can I start?
You can go for it.
All right.
Oh, that looks nice. Yeah.
Okay, cool. All right, so I'm going to go onto my. This is my big machine. 90% of disk used because I am bad at cleaning up files. But I've got some stuff here. All right, so this is the 500 gigs of RAM is here, and most of it is free, which is good. So we won't need very much of it. Yeah, so life's good. Running some experiments, so that's okay. Okay, so the first thing I want to show you is how unhinged some queries can be. So what I have here, this is really from Microsoft, Orca's clicks. This is a real web click log from Microsoft. I'm just going to do some shuffling and check. So this has some huge amount of, so I don't know how big that is. 18 million, basically 18 million queries with the associated clicked web page, right? So if you look at these, I think they're sorted somehow. People are looking at GitHub, they're clicking, this is their query, and this is what they're clicking. Can you see it okay? Yeah, it makes sense. So YouTube, obvious stuff, right? People are literally searching exclamation marks. See, that's kind of a hard query. What are you going to return for that? So then they're clicking Wikipedia, inverted question and exclamation marks. But if I just cut into this a bit and we have a look, and by the way, this could be a bit not safe for work. I don't know what's in here. These are real people. So 90-degree angle calculator. 90 days prior to date. See, these are, you have to answer good stuff to these, but you don't even know what they want, right? These are all really early on because it's sorted. I think it's sorted according to like lexicographical order or something. So if we cut a bit further in, we'll get through the numbers and stuff, and maybe we're in A's now. I'll stop here. So I don't know what that is. There's a university. The file, how big's the file? It's a symlink, so. It's not very big. It's 1.7 gigs. No, VI got to M already. All right, so the point is, look, maple syrup. So I just hope the point I'm just trying to make is that it's hard, right? It's not an easy problem to solve. What I'll show you now is I built a really bad simple search engine in Python. I'll give this to you for free later, but it's very bad. I'm not very good at Python, but I tried to make it somewhat nice, no type hinting or anything. Basically, it takes a TSV that has the doc IDs preset with a tab separator and then a document, so like this. The real document, I do have a couple of collections here. So it's like snippets from Bing's index. So basically, it's a passage collection. They've taken web documents and chopped out like passages from them. So it's some stuff about the Manhattan Project. there's heaps of stuff in here though. And so we're going to treat every document as a dictionary where the key is the ID, the value is a string that represents the text in the doc. Very lazy, so if exceptions happen, I don't care. I just ignore them and pretend life's good. But yeah, I'm essentially going to take the document ID and the text, I'm going to put in a dictionary, I'm going to say, okay, I read those documents, and then I can build a search engine. So my search engine will take the dictionary of documents, and all my index is it's a dictionary, and it maps a word, a term, so like hello, to a list of tuples where the tuple's first element is the ID and the second element is the frequency. So exactly what I showed you in the thing before. We do a little bit of easy tokenizing. We're just going to replace white space and we're going to lowercase all the text, right? So anything uppercase will be turned to lower, and we're going to just get rid of any random white spaces or non-alphanumerics. Now, we've got as input this dictionary of doc ID to content. So we're going to iterate across those. We're going to tokenize the content to get a string. What this does, has anyone seen counter before? It's just a lazy way to basically count how many times each thing's in a set. So it's going to return the word and the count as pairs, right? Then I'm going to go through those and say, okay, for each word and frequency, if I haven't seen the document in my index, I put in an empty list because I need to be able to index into that list. If I have seen it, or basically the normal case is that I can go to that part of the index and I can append the doc ID and the frequency tuple, right? This is exactly what I showed you in the demo, in the talk. I also have a dump list command that basically says, given a user's query, take the set. So if a user's query has words that repeat, I don't care. I just get rid of the repeats. And then I'm just going to print basically the index representation of that. Or I'm going to say I didn't find the word. Now, the more interesting thing here is I'm going to do a ranked AND. So the AND, remember, is that every word in the query has to appear. And I'm going to do a very lazy ranking today. I'm just going to rank documents by the number of times the words appeared. So I'm going to count the frequencies, right? And the ones that had the most occurrences will be put at the top, and the ones that had the least will occur at the bottom. And I'm going to give you a ranked output, and then we can go and look at them. So basically, you check and find out which terms do I have in my index, right? And if you've got none, you say, okay, sorry, I don't have anything for you. Otherwise, you build a list of kind of lists, right? You're saying these are the lists that correspond to the queries. And this pointers thing is like a set of indexes into each list. So the first element of pointers tells me which index into that list I'm currently accessing, and I'm going to be increasing them as I go through. I found out about this yesterday. This is cool. Has anyone seen all before in Python? I don't know how I didn't know about this. I'm a noob, obviously. But this is really cool. It basically will continue looping while this is true for all of the elements in the range. But basically, what I'm going to do is I'm going to iterate across the lists while every list is still active. At the point where any list is inactive, I stop because I'm doing an AND query. The thing I'm interested in right now is the maximum document under each cursor. And if every document cursor is pointing to that same candidate, I'm going to score it. It's a match, right? So I'm going to go in, and this looks really ugly. Don't do this. Paul Verbeek will kill you. But basically going to go in and say, okay, I know I've got a match, so tell me how many times the word occurs. I'm going to sum those up, and I'm going to put them in a results list. And then I'm going to return the results, right? And the other thing that can happen is that you're kind of misaligned, right? So one of your lists is pointing to document 10, but the next list is pointing to document 12, and the next list is pointing to document 15. In that case, you didn't find a match, so you're going to move the ones that are lower than the current maximum, you're going to try and move them up to that maximum, and maybe they'll overshoot and you'll go around and try again, right? So that's actually kind of what you have to do to make a search engine. So what I'm going to do is load a TSV, build an index, and then I'm going to take a query in and I'm going to try and run it, okay? So that's what we're going to do now. Oh, by the way, we're going to take the results list and we're going to sort it. in reality, you wouldn't actually keep a list of every document. You would just keep a heap of the best K documents, and you would throw things out and put new things in. So like at any time, if you know what a heap data structure is, it's basically a semi-sorted structure. You would keep like the K highest scoring things you've seen up to the current point. If you score something and it's better than the smallest thing in the heap, you throw the smallest thing out and you put the new biggest, better thing in. And you keep doing that. At the end, you've already got your K things. You don't have to do any magic sorting or anything. Okay, so this I believe works. I was messing around with it yesterday. By the way, test has, I think, 100,000 lines, right? So it's small. I've got a bigger one, but we'll do test first. And you know, I'm very sure that you can all do something better than this and probably spend less time than I did on it. Now you've got the tools, you know how to do it, okay? So indexing takes a little bit. I forgot about that. So the query process is bad. I have to tell it I want to do an and because I was going to implement or and then I was too lazy and I didn't do it. So, so if I do like hello world, basically it's saying document that is the best one because the combined frequency of hello and world was 4. If I then go back and, I always forget how to, there we go. Let's do that. So if I grep for this in test, then you can see that like it's about hello world programming. So it's a good answer, right? And then you can see that it's got hello world and then worlds over there again, worlds over there again. So I think there's my 4. These ones won't count because they'll be treated as an individual separate word, right? You can also do things like, and you can do a single word. So look, amazing. Can you believe it, guys? UQCS is in here. And it's the last document. Who would have expected such a thing? Wow. There's a poem about UQCS in my corpus. Thanks, Gemini. No, that's so bad. I'm glad I'm not recorded now. But yeah, so this is kind of how it works. You can also, if you want to, just a quick refresher on how this works. This is just saying UQCS occurs in document 100,000 once. That's what your index looks like. If you want a more popular word, you could do something like dump and of course it occurs a lot because it's an English document collection, but you might be able to find, and you know, this is only 10,000 or 100,000 things. So this is very small. This is like a toy index. But any queries? Anyone has a? I won't do a conjunction, but I'll dump and the of who. Who was wrong. But yeah, I mean, that's kind of how it works. Now, to give you just a quick sense about real search engines, like the ones I was showing you right at the end there, I've got a little demo. So there's a code base I help maintain called Pisa, and Pisa is essentially like a sort of highly optimized search engine that we use for running experiments and stuff. So I've got an index here. This is 8.8 million passages. So I just showed you 100,000, but I've got 8 million of them or 9 million. And we're going to do top 10 retrieval in our kind of best possible scenario setup. Now I've got a random bunch of queries here. The queries will look a little bit weird because they're pre-normalized. So what really happens is like, this is college here. So you've chopped the E off because of the stemming I was talking about. So this is something about like community college, Jeff State Community College probably, or Jefferson State maybe. So this is what the queries look like. There are, what, is that 100K? So there are 100,000 queries. How long do you think it's going to take me to run them all? I have to load the index into memory first. So the index is loaded now. It's gonna run them all a bunch of times and then it's gonna tell you how long it took. So it took less than a millisecond on average to run each of those queries. 740 microseconds, right? per query. So 6.9 milliseconds for the hard ones, okay? So I just ran 100,000 queries 4 times in the time after I press enter, okay? That's how a fast search engine feels, right? And if you don't feel anything, that's fine, but it's, okay, it's a bit of a vibes thing, but yeah, I mean, and this is of course using a bunch of threads as well. So this is kind of like a production scenario, right? So they're the main demos. I just wanted to give you some idea. Now, if you want to find like, I guess the big V1, this collection's not very big. So it's only 3 gigs of text, right? So it's not super interesting, but yeah, I guess it's just nice to see kind of what you can do with some years of boredom and patience. All right, is there anything anyone wants to talk about, or otherwise I'm pretty much done. We can eat pizza and, well, you can eat pizza. Yeah.
How much is the computer cost?
This one?
Not your ThinkPad.
Yeah, the one I'm on, Annapurna, 23K.
Is your phone laptop, right?
No, this is my UQ funding.
Okay. Oh, right.
Yeah, it's got a couple of GPUs as well.
I thought you bought like 500 gigabytes of RAM.
No, UQ bought that for me to support my research.
But so it's like exclusively for you?
Yeah, this is in my office. This is my workstation. Me and my students use this, yeah. Yeah.
We try not to think about it.
Yeah, I don't know. It'll be expensive now. I haven't looked recently, but
DDR4, DDR5 RAM?
I can't remember. I bought it in 22, so yeah,
Probably DDR.
yeah.
It's 22.
Yeah, that's horrifying. That's horrifying.
Does MemInfo tell me? I can't remember. Anyway, yeah. So yeah. Probably. I don't know. I just have fun and don't think about it. Thanks, UQ. Yeah. Any questions about any part of the search thing or whatever? Yeah. The data. Oh, right. So that's basically people at Microsoft that orca stuff. So they have released these. These are like, this is a click log that you can use to basically train models. So the idea is that if you know, if active yeast, great, active yogurt, if you know, like for a query, which things people are clicking on, you can go and download the things and then you can kind of train models that can be aware of intent, for example. So you could use this to like build a query auto suggestion ranking engine, or like this could also be used for if people click like, I'll try and give you a quick example. I mean, I don't really like the active yogurt or active yeast, but if I grep for this, which possibly doesn't occur at all, but I'll try. Okay, it occurs a lot. So the idea here is that you can build like a bipartite graph of queries that people submit and the documents they click. So if basically what I just did is I found a query that was, what was it again? Yogurt something. And I said, okay, if people issue that query and click this document, what other queries do people issue to click that same thing? Because then when someone comes along and puts yogurt as their query, I can suggest them that maybe they also want to search for yogurt, right? That kind of makes sense? So that's why this is a resource that we can use. It's publicly available. You can go and download it and play with it. Yeah. Any other queries? Questions? Yeah, nice one, hey? All right, I bored you all to death. Well, I'll hang around. If you want to chat, I'll be here for a little bit. So, yeah. Oh, is pizza here? Yeah. All right, we'll go and eat pizza. Thank you very much.